The maker and tinkering communities may be small communities worldwide, but they contain some amazing people. Today, I have the great pleasure of talking to Dan from Dan Makes Things, a channel I've followed for some time around Dan's companion bipedal robot, also some of his other projects. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT and other fun tech. Remember to subscribe and join the community. Please do hit that like button on the video and subscribe for more. I'm delighted to welcome Dan from Dan Makes Things to the channel today. So hello Dan, welcome. Thank you very much for joining me.
Thank you for having me. It's great to be on the show.
I appreciate it. For those of you, those few people out there in the world of YouTube who aren't following you, do you want to tell us a little bit about who you are and your channel and a massive presence on YouTube and Instagram?
Yeah, of course. So my name is Dan. I'm a software engineer, and I've been a software engineer for about 20 years. And a few years ago, during lockdown, I started dabbling in electronics and robotics and that kind of thing. And what I was trying to do really was just teach people what I had learned so they could follow along on the journey of kind of me exploring with these things. And I like building things. I'm not very good at making names for things. So I created a YouTube channel, which was Dan Makes Things. And I started posting as I started experimenting. And that has grown over the last 3 or 4 years to a fairly decent sized Instagram and also YouTube channel as well. So I post infrequently, but hopefully interesting videos around robotics, electronics, 3D printing, and that kind of thing.
It's a very interesting channel and I enjoy it a great deal. And, I know a lot of people do. How did you find that jump from the world of software to making things actually move? It's one that lots of people I think aspire to, but it isn't the easiest jump, I know from my own experience.
Yeah, and it's an interesting thing because when you're a software engineer, especially if you're not front-end software, like making websites people can see, nobody really kind of gets to experience the things that you've built. You can't show somebody and say, look, I made this thing. Whereas with things like this, it's really visual. It's a really interesting and hopefully, impressive thing, especially for people who don't know anything about it and they see it kind of goes over their head a little bit. So it's been quite gratifying to see the reaction that people have had to these kinds of things. But it was a hell of a transition. So obviously, I don't have a background in electronics. I self-taught everything around this sort of area. And I did that mostly through things like YouTube. And so learning my way from other people's examples was really kind of quite empowering because it isn't something that I've ever been able to do before, And it's one of the key tenets of all of the work that I do is that I try to make it open source. I try to make it so that I've got a guide so that people can follow. And I try to document it all on YouTube, of course, because I'm effectively paying that forward and trying to make it so that, if I can build this, then you guys can build it as well, even without that prior kind of technical knowledge. And I will say that the software engineering background helped, but most of the work that I do isn't in the software. It's mostly in this kind of thing. It's mostly in learning to 3D model and 3D print, and how do you connect specific electronic modules together in order to do what you want to do. So it's a very different path to my day job.
So the companion robot, what I very much think of as DB1. It is, because he is, isn't he? Was that the first robot, or did you actually tinker with some other ones first?
Yes and no. So I did have a bit of a mess with, getting some motors, getting an Arduino, and kind of trying to build something. And I had no idea what I was doing back then. So I had a 5-volt battery pack, and I thought that could power the motors with a boost converter and that kind of thing. And of course, it wouldn't move because there wasn't enough current. And all of those sorts of things. So I had a few ideas, and I didn't have a 3D printer, so I built some things out of wood, and it was slow and hard and tedious. During COVID and during lockdown, I started messing around with an idea I had of a little desktop companion robot, and it wasn't anything like this. At the time, it was a cube. It was this small cube that would pop up from its base, and it could kind of turn its head and move, and it had strips of lights going all the way around the inside of the thing. And when I started to build it, I learned so much about how not to make something like that. I learned that you can't make it do that and still have room inside for the brain and still have room inside for the lights and the power and all of that stuff that I really thought in my head would work. I started to get a bit disillusioned by all of that. And then at the same time, I was, as you probably guessed, I was playing that Star Wars game Fallen Order that came out, and really fell in love with the character from that. And I thought, what, this would be a really nice thing to have as a desktop companion, even if it can't climb on your back and run around with you and do all the things that it does in the game. I like the form factor. I like the look of it. I thought it was very impressive. And so coming from that background of not knowing what I couldn't build, I didn't know how hard it was going to be. I didn't know how long it was going to take. But it was quite interesting to go in and try anyway. And so I started with various versions. And I think this guy is probably version 4, where the first 1 or 2 versions just weren't even worth keeping because it just didn't work. It couldn't support its own weight. It was like a baby deer. Every time I tried to stand up, it fell over and that kind of thing. But I gradually learned more about the mechanical side of things and the electronic side of things, and got to a point where we've got something that will work, will move around. It can't walk, but it can animate quite effectively. The servos can hold its weight well. It can balance by itself, and all of those things that I wanted it to be able to do. Tracks faces, and it can kind of, if the microphone and speakers work, it can interact with you. And obviously now with things like ChatGPT, you can make it smart and all of that fun stuff. So I think I kind of got myself to that goal, but it took a lot of years, and it took a lot of different versions of that same project. And again, that's why I was really keen to make sure that whatever I did, other people could build as well. Because, if I could have just taken something that somebody else had and started from that point, I would be a hell of a lot further on now than I am. So it's been a really kind of interesting opportunity for me to try these things out.
Though there is quite a lot of learning and knowledge that goes with that, of going back over lots of your videos to understand what IK is, and how to do all these kinematic algorithms, how that works. Yeah, there is quite a lot. I mean, even just getting the thing to stand up and actually picking servos and calculating the strength through the gears on there, that's not easy in itself.
That's true.
And you said you have 1 or 2 that didn't stand up. I can imagine that, because
Yes, that's right. And that has been a challenge. And I have been through a number of different types of batteries in order to get to this point. And I've ended up settling on a 18650, which looks, if anybody isn't familiar, it looks a little bit like one of these, which is effectively like a large AA battery sort of a format. And the reason for that is that you can buy ones that have protective circuits built in for over discharge and overcharge protection and that kind of thing, but they still allow a reasonable amount of current. And so in this project, we actually have 3 of them running in series, and then all of that goes into a DC to DC converter in order to kind of set the right voltage. And I've tried to keep it so that the servos are all 5-volt tolerant servos, and obviously the Arduino and the Raspberry Pi are 5 volts as well. Again, to try and keep it simple, because one of the challenges with components is, for example, this. I've just bought this. Try that again. Just bought this brushless DC motor to try and experiment with those things, but it's a 12 to 24 volt motor. So if if even running it at 12 volts, you'd have a challenge getting that working. With this, you'd have to rebuild the whole battery system. You'd have to kind of put more power into it and so on. So the goal with all of this is accessibility, making it cheap, making it affordable. But then, as you say, you need powerful enough servos to be able to support the weight. And how do you calculate that? And of course, the challenge there is you've got, for example, on here we have the servo in the ankle, we have the servo in the elbow, if you like, or the knee, and then you have one in the hip as well. And you can calculate, based on the stall torque, you can calculate how long the leg can be and have that servo still comfortably supported. So these legs are as long as they are because I can't make them any longer without putting too much strain on the servos. And so like things like that, which, again, the maths is out there and there are calculators online that can help you do that. But you really need to understand what it is that you're doing, and it's a hell of a thing. And then these servos at the top were used in the original sort of smaller version. I had a mini one that I built first of all, and they're quite high powered as well. So they have a higher stall torque than some of the cheaper micro servos that people typically use on projects like this. And I've had people build that project and have it where it can't stand and it can't walk. It can't walk anyway. It can't stand and it can't do what you want it to do because they were just using a slightly cheaper servo that just didn't have that same power. Yeah. So it is a real challenge, and it's just about getting that understanding and that awareness of what it is you're trying to do before you start will save a hell of a lot of time.
I have the challenge myself when I go to buy a servo. There is a whole raft of metrics there, and knowing which ones to look at and which ones are important for your project is something that only comes with a bit of experience or someone else guiding you to look for the stall value, look for the tolerant voltage. Those are what you want to to be able to actually say, will it be able to do this? But yeah, no, it's fabulous. No, very good, and really useful stuff online. You mentioned Arduino and Raspberry Pi. How did you settle on those two? Were they just what you had or experience, or was there a conscious choice?
So the interesting thing is that, bear in mind, I've been doing this for about 4 years, and in that time, so many things have changed. So when I first started, I got a Raspberry Pi 3B Plus, which was just released at the time that I started the project. And I used a Arduino Nano, I think was the original version. Because, Arduino's lots of different form factors, but I was always going to try for something that was small. I was always going to try for something that was 5 volts, just to kind of keep things simple on the servo side. And now there are tons of different kinds of Arduinos. There's the ESP32. There is obviously more powerful Raspberry Pis, but there's also the Jetson boards, Jetson Nano, and a few of the other ones that I'm not that familiar with, but other people have tried to build this project with those boards and varying degrees of success because there are different benefits. And I think the answer is I settled on the Arduino and the Raspberry Pi because I kind of knew them a little bit from previous projects, and they seemed like they were going to have the most support. You're going to have the most chances of getting these things working if you wanted to get them working. What I've found is that the Arduino is obviously quite limited. Certainly an Arduino Nano, it's not particularly fast, especially when you compare it to things like the Pico or the ESP32. The Raspberry Pi, this is now running a Raspberry Pi 5. And although that is fast enough now that you can do some real-time stuff like face tracking, where the 3B just kind of couldn't quite do it, it just didn't have that power. You have other issues like compatibility with modules. So the microphone and speaker that I'm using are both MEMS components. They don't have compatibility with the Pi 5, or at least didn't when I looked at them like a few months ago when it was released. NeoPixel support is still a problem on the Pi 5, and so you actually have to have a separate module that has its own microcontroller in order to just control the NeoPixels. And so there's a lot of challenges with adopting new technology, and it's about finding that balance between something that will make your life easier and something that actually makes it much harder because you spend time troubleshooting issues that you maybe didn't have on an older version of the same board. And so that in itself has been a real journey. And it kind of leads on to this thing, which you may have seen in one of my kind of more recent videos, which is let's see if I can bring it a bit closer. So this is an ESP32 PCB that has as many modules as I could cram into it that were all 3-volt compatible. So the idea is that you can run everything off 3 volts. You can connect more smart modules like, so for example, for facial detection, this is obviously Raspberry Pi running the Raspberry Pi camera, but you can actually get a thing called a person sensor by Useful Sensors, which is a small module. It's not particularly expensive. It is specifically designed for detecting faces, and that's all it does. And it sends it through I2C, the data, not the actual images. So it's a lot lighter on processing power and all that sort of stuff. So you could do the same as I'm doing with my Raspberry Pi 5 and all of the power and all of the complexity with one little module and an ESP32. And so what I wanted to try and do was see, like, can we make this more accessible? Can we make it lower power, and can we make it easier for people to onboard with by just switching up the technology that's used? And of course, 4 years ago, that wasn't really an option, but now there's so many changes coming out that you can really improve the way that you do things by kind of knowing about a few of these things.
Are you doing that on Python or C?
So I'm primarily working with C on ESP32, and there's only really one reason for that. So I have another thing that I've been working on recently, which is this new project, which is it's effectively a Bluetooth controller with a few fun additions, and this is using a Pico, and it relies quite heavily on controlling neopixels as part of it. And what I found when I was doing experimenting with that is that the Python script for neopixels, the library, isn't particularly advanced compared to the one in C. So that's my limited exposure to this, is that some of these modules are more developed in the C and the Arduino kind of language rather than using MicroPython. And so I think it really depends on what you're trying to do and how the features that you're trying to add and build on it in order to understand which technology and language to use. I'd be interested to see whether you found the same thing, because it's my first time using Python on the Pico, so it's a very, very limited view.
I absolutely have. I mean, I spent years of my commercial world as an architect, an IT architect, helping us use the right technology for the right problem. And because as a developer, and I'm as good as, and as guilty of it as everyone else, I know that, I tend to favor one setup and one language, and basically, wander around with my hammer saying, oh, this has got to be a nail. Let's hit it. Which isn't really how we should go about it. So we should, choose stuff. I use Python a lot, but I tend to use it on higher level boards. So I would tend to use it on Raspberry Pis. I use it on servers. I use it in cloud services. When it comes to the Pico or ESP32, which I've also played with, I tend to go C and C++, actually mainly C++. And one of the reasons for that is actually FreeRTOS kernel, the ability to run multitasking. Because as soon as you start communicating with anything, if you've only got a single thread, it is really, really painful to have to keep jumping back from, has any data arrived, to actually doing something. And to run those loops is just too hard. And it's so much easier to just use a proper kernel. And that's what you've got on ESP32, which is, I presume, what's allowing you to run all those modules.
Yeah, exactly that. And I will say on the Raspberry Pi 5, I have been using Python. We have this whole framework that we've kind of built up of independent modules that control all of these things. And it worked pretty well. But Python is not the most performant language when it comes to real-time systems, and there is obviously a cost in performance to running it. So it's a really difficult choice to make, but it totally depends on the use case. I think that's the challenge that people would have. But I think it's probably fair to say I favor Python over C if I can get away with it, which is why I was excited to try it on the Pico. But my background is kind of in both. I started out in games development, and that was C and C++, and then I moved into PHP for a lot of years, and then a handful of other things as well. And I kind of self-taught Python, but I immediately liked that language because of the the way that it's structured. But you've got to pick the right tool for the job, as you say.
I agree, and Python. I like Python a lot too, and it is so much easier working in that than it is in C and C++. To be honest, with the new Pico 2 and the RP2040, one of the things that's interesting, I think, from a robotics point of view for us, is that's got a mass coprocessor on it, or in fact, mass coprocessor on both cores, and its floating point mass is therefore more than three and a half times as fast as we could manage in a library. So things like doing forward kinematic and reverse kinematic algorithms on the microcontroller starts to look possible. And that takes away some of the code that actually I think needs to be in C and C++, away from what we need to run on our Raspberry Pis, which I think can be more about planning and, TensorFlow and other AI components, rather than worrying too much around, calculating what the position of the angle needs to be of every leg.
Yeah, being able to delegate some of those lower level decisions to something that is more suited to the task is definitely worth investigating. And to be honest, that's one of the reasons why it's got a microcontroller directly connected to the servos, and then the Raspberry Pi is that higher level brain function, and that connects to the microcontroller through a serial connection. And the idea there was, well, if you just wanted to animate, why should the Raspberry Pi be involved in that? The Raspberry Pi can tell the Arduino what it thinks it should do, and the Arduino can work on the servo positions independently. And having something, as you say, like the Pico 2 would make that whole process a lot easier and smoother.
So as a robot builder, what are the key tools and techniques that you rely on and that you think people should be focusing on as they adapt to follow in your footsteps?
I mean, it's really interesting because there are so many different things out there, and I don't consider myself to be a domain expert on any one of these tools. I tend to go for tools that are recommended by hobbyists in order to understand, that there is good support for that thing, that I can potentially get help if I need it. So one good example would be for PCB design. I use a tool called KiCad, and it's spelled KICAD, but it's pronounced KiCad. And the idea there is, you can make your own component structures, you can put them in place, you can build your own PCBs and have those files exported, and then send them off to a PCB manufacturer, and they'll do all of that hard work for you. And I absolutely love that, because I hate breadboarding and perf boarding and kind of putting these prototypes together, because they're bulky and messy and it's hard work. And also it's hard to reproduce, because I want people to be able to do that. And the only reason why I use KiCad is because I went on a forum and a lot of people recommended it. But there probably are better ones if you're willing to pay, and there are probably ones that are easier to learn if you just want something that's really simple. I would say one of the key things that's really advanced my progression has been 3D printing, and then learning how to use a microcontroller. I think the Raspberry Pi is a great tool. I think it's quite advanced in terms of the learning curve if you want to do robotics with a Raspberry Pi. The voltage difference between what you can do with some modules and the 3-volt logic of the board. The Arduinos and things like that are 5-volt compatible really make that a lot easier, because there are a lot of 5-volt modules out there, and some of them are also 3-volt compatible, so you can use them in multiple places. But I've found that a lot of these things are still 5 volts, and you've got to kind of make sure that you're not feeding the wrong voltage into the various components and that kind of thing. And from a 3D printer perspective, there are tons of 3D printers now, of course, as well, and it depends on budget, and it depends on all of that. And I actually use an Ender 3 Pro, which is quite badly reviewed now. There is a lot of flack on the internet about that, because people, every time somebody posts saying, I've got this Ender 3 Pro or Ender 3 or whatever, and it won't work or it doesn't adhere to the bed, so many people give them a hard time for picking that printer. But mine has been a real workhorse, and I've had it for 2.5, 3 years, and it's never had any issues at all, apart from when I use cheap filament and it ends up causing blockages and that kind of thing. And that's not the printer's fault. I think the challenge is you've got to learn how to use the tools. You've got to take the time to use the tools and learn how to use them properly. Otherwise, you end up where you're making life harder for yourself in the long term for the sake of taking that kind of short term. So for me, it would be, learn how to make PCBs, learn how to do 3D modeling. I use Onshape for 3D modeling, but only because, again, you can share the files. It's all open source and available. You actually can't make private folders and private designs in Onshape without paying this ridiculous license fee. So that's, it's fine from my perspective. For code, things like GitHub, if you don't know how to use Git and GitHub, it's a whole different world of things that you can learn about, and you can get accessible code and use them in your projects. And that's definitely a big one as well. Using the Arduino IDE, you don't have to do anything complex, but just being able to get in there and use the Arduino IDE is a really useful thing for all of the microcontroller boards. And yeah, I don't think there's any other areas, but those are the main ones, definitely.
No, interesting. And, I agree with you. KiCad, or I mispronounce it as KiCad, it's something I use as well all the time. I think the challenge, though, is learning all of these tools and keeping fresh on all of these tools, because it's quite a large tool set that you end up needing to maintain as skills.
Yes. And if you don't use a tool for a while, you tend to forget. So this is part of the reason why I document everything, so that I can refer back to it later. So KiCad's a great example. I forget every time how to use it, and I have to go and check my notes every single time because there's so many little things that you need to remember about it all. But it's very empowering, and I joke that it's like having a superpower, because you can, you need something, you can design it, you can send it off to be manufactured, or you can print it in your own 3D printer, and then this thing exists in the world. And there's nothing else like that you don't have to spend hours and hours using tools and using machinery in order to make it happen. So it's a really exciting time to get involved in this kind of thing. And I mean, if this existed 20 years ago, I would have been doing it 20 years ago, but there was nothing. You really had to do everything the hard way. So, I mean, making it more accessible to people who wouldn't otherwise be able to do it is such a bonus. And I really like that about this hobby at the moment.
I absolutely agree, and I did try to do some of this 20 years ago, and it was just too hard. Absolutely. So, things have come on hugely and really become viable. So, if you went back and you were going to give yourself some advice, what would be your advice starting on this journey?
That's an interesting one, because, I mean, we've talked about the technologies used and whether we do things differently. And I mean, bear in mind, if I was starting it at that same point in time, there wouldn't really be much in the way of other options. I think the big thing for me is that I always try and over-engineer a solution to something. So, for example, I wanted BD1. I didn't want something that looked like BD1 for the sake of YouTube and Instagram. I wanted to build the thing. I wanted to make it work and behave the way. And so what I ended up with was a solution that allowed me to do a ton of configurability, all of those modules that I added, all of the work that I did to build the software that it runs on. But if I was just looking to get up and running with the hardware and something that could move around and could kind of animate like that, that's 10% of the work. And I think my challenge is that I try to do everything at once, because I want to make everything work and then work on pulling it all together into one cohesive project. But really what I should have done is started with one thing and got that working perfectly first time, and then built on top of that. And I think that's the reason why I've ended up with so many different versions, but none of them will actually kind of move around and behave in the way that I want them to. This guy, I was planning on powering it up to for the background shot, but it doesn't it doesn't interact with me. I've actually put it into demo mode for when we went to Maker Central earlier in the year. And it's because demo mode at least shows you some of that functionality and some of that movement. Whereas otherwise, it effectively just stares at you all the time. Like that's the base default functionality, is this head that just turns and looks at you. And I think I could have gone a long way by just taking 2 or 3 of those features and really building on them, rather than that kind of breadth first approach of I want every module, and I'm not going to even take it further until I've got every module in place. I think that's the challenge. You've got to limit the scope of your project, and that's something that I didn't do, and therefore it just ballooned and ballooned until, yeah, to be fair, it does a lot, and people are building on top of that and adding their own functionality in the community. But from my perspective, I could have probably made this a lot more usable by just limiting my scope a little bit.
I think that's a really, really good advice, and advice I could take as well. So where's it going to go next? What's the next plan?
There's so many different directions that I can take it. And the big question I get asked in every time I do a presentation on this, or I kind of speak to anybody, is, when is it going to be able to walk? Can it walk? And when are you going to do that? And of course, the limiting factor is that's a really hard problem to solve. And I could either spend the next, couple of years in my free time kind of going through just making this thing walk forward and turn, which I'd love to see. But it's quite a difficult thing for me to be able to do myself. So what I'm hoping is that there'll be some person far more skilled in that area than me who joins the community and kind of wants to see that happen and puts the effort in to make that. And I'm more than happy to support that side of things. But for me, there are so many different other areas that I can improve on it. There's a couple of things like the way that it is built currently allows, let me put it in frame, allows the hip joints to kind of move on a joint at the bottom, but they're not attached to anything. So you'll see it's very wobbly. And what I'd like to do is to be able to put some actuators in to control that, so that you can position it a little bit more accurately, maybe make it so the foot can turn outwards and inwards and that kind of thing, which again could feed into that idea of being able to make it warm. And then beyond that, a lot of the work is just around how can I improve it to make it a more functional project, make it so that it can interact with people in the way that I want it to, and kind of build on that side of things. And one of the really interesting ideas is you can stream, let's say, camera footage from a microcontroller like the ESP cam to a more sophisticated machine like a laptop or a computer. And then you can have that do the processing and then send results back. And so there's an opportunity to swap out all of the high-powered electronics for a more simple microcontroller setup, and then have the brain kind of off-site, as it were, and kind of in a local machine, but not on the robot itself. And I'm quite interested in trying that out, because there's an opportunity there to be able to make the battery last longer, make it lighter, make it easier to transport. And even if you take it to an event, you can have a laptop running in your bag, connected over Bluetooth or Wi-Fi or whatever it might be, and have that kind of processing going on one of those devices instead.
Well, thank you very much, Dan. This has been an enlightening chat, and we will all keep watching the channel and see how things progress.
Thank you very much. I appreciate you having me on.
Dan's work with these companion robots and other projects are inspiring. Every time we chat, I get inspired to look at the area of companion robots. I just can't decide what sort of companion robot I want and how I would want to use it. Do let me know in the comments if you enjoyed these sorts of fireside chat format videos. Your feedback's always really useful to me. If you like the video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video. Remember, I'm saving these up to get myself to open source in San Francisco next year, and I'd appreciate your help in getting me there. And I'd hope to see you there too. Thank you very much for watching. If you enjoyed the video, then please do hit that like button, and please subscribe to my channel so you don't miss the next video. Bye bye for now.